Solve the question 3.12, and it is given that a ball is dropped from a height of 90 meter on a floor. At each collision with the floor, the ball loses 1/10 of its speed. Plot the speed time graph of its motion between 0 to 12 seconds. So there is a ball, right, and it is dropped and it rises again, but this time its speed is going to be 1 by 10th of what it was when it fell. All right, and then again that ball is going to fall and then it loses 1 by 10th and then it goes up to this height and this process goes on. So we have to plot what happens between 0 to 12 seconds. All right, so first thing what we have to do is we have to calculate what is the time that the ball is going to take when it falls down. All right, so what is the time taken to cover this part of the motion? So the height is equal to 90 meters. All right, and from that we can calculate u is given as 0. So from that we'll calculate from s is equal to ut plus half at square. All right, here you are going to have 90 is equal to 0 plus half into g. What is g here? 9.8. All right, g is 9.8 meter per second square. So you substitute 9.8 into t square. So we have to calculate what is t. And here you will be getting t square is equal to 2 into 90 divided by 9.8. So from this t is equal to square root of 2 into 90 by 9.8. And the answer will be 4.3 seconds. Alright. So this is the first part of the motion of the object. Alright. So in the graph, side by side, we'll be drawing the graph also. So to understand exactly what is happening. So let me draw it below. Okay, so this is time and this is the velocity of the ball. So we are going to start from 0 to 12. Right? So this is 12 seconds. Now the ball is going to drop, right? When it falls down, its velocity is increasing. Now when the velocity increases, how much time does it take to hit the ground? So it is going to take 4.3 seconds, right? So roughly around at this time, the ball is going to get a velocity that is a maximum velocity. All right, now what is this velocity going to be? What is the value for this? Okay, what is this point? So for that we need to calculate using this time t, using the equation v is equal to u plus at. So you will be getting v, final velocity, is equal to 0 plus 9.8 into 4.3, right? So v is going to be 42 meter per second. Okay, v is going to be 42 meter per second. Now the ball falls here. Okay, and this point it is going to have 42 meter per second. Now when the ball hits the ground, it is going to lose 1 by 10th of its velocity. 1 by 10th of how much? 1 by 10th of this 42 meter per second, right? So what is 1 by 10th of 42? So it loses, I'll write here, it loses 1 by 10th of its velocity, right? So it is going to lose 4.2 meter per second. Okay, this much velocity is lost. All right, so the velocity that will have finally to go bounce back. Okay, so this object is dropping and then it's going to bounce back. So what is the initial velocity when it is going to bounce back? I can say it as u dash. Okay, so what is u dash going to be? It will be equal to 42 minus 4.2, and 42 minus 4.2 is going to be 37.8 meter per second. Now clearly it is going to lose that velocity 37.8 in that instant itself, because it is at that instant that the object is going to hit the ground. So this, let it be 37.8 meter per second. Now after this what happens? The object is going upwards, right? So here first the object was falling and then now it is going to go upwards. So now when it goes upwards, it's going to constantly lose its velocity, and at the highest point it will become equal to 0. Okay, so v dash is going to be equal to 0. Now what is the time that it takes to do this? So for that we need to do 37.8 is the initial velocity plus g into t. What is g here? 9.8 into t is equal to final velocity. So final velocity is equal to 0. right? And since the object is going upwards, we can take acceleration due to gravity to be negative. So from this we can write 9.8 t is equal to 37.8 and t is going to be 3.9 seconds. Okay, so from the highest point, from the ground, the ball is going to take plus 3.9 seconds to come to rest. Okay, that is to come to the maximum point. So here v is equal to 0. So first the ball was dropped and then now it is going back again. So already we have 4.2. Okay, so 4.2 plus 3.9 is going to give me 8.1. So let me mark 8.1 here. Alright, so this object is going to move above upward direction in 3.9 seconds. So at 8.1 time, it is going to be reducing its velocity. Now, if it is going to take 3.9 seconds to go up, it will take the same time to come down. Okay, so if I add further 3.9 with this, what am I going to get? So it is 0 and then 9 plus 3, 12. Alright, so 8.1 plus 3.9 is going to be 12 seconds. So at 12 seconds, the object will reach the same velocity here. Means it is hitting the ground at 12 seconds. Okay, so this is actually your downward motion because the velocity is increasing. Okay, and this is the upward motion because the velocity is decreasing. And then once again here, this is your downward motion. So the ball falls down, goes back and then comes again in 12 seconds. Okay, so this can be continued. Okay, so again I can draw a graph like this. So it can continue, but in this question they have asked only from 0 to 12. So we will restrict our graph up to this. So sorry about the scribbling, but this is the actual graph that you're going to get. I hope you have understood. In the next question, 3.13, they are asking just to give explanations with examples. Okay, magnitude of displacement, sometimes called distance, over an interval of time, and the total length of the path covered by a particle over the same interval of time. So we have to find the distinguishing between. Okay, so what do we mean by magnitude of displacement? First of all, we need to understand what is displacement. So if an object is traveling, let us say from A to B, alright, and here we have to consider only one dimensional motion. Okay, so if the particle travels from A to B, okay, and again it comes back to C, midway between A and B, right? So the total distance of this particle is going to be that let this distance be x. Okay, and then he came back by an amount of x by 2. So the distance is going to be x plus x by 2, whereas the displacement is going to be the difference between the initial and the final position. So initial position is A. So let us imagine this to be some random value. From that you have to subtract this C, right? So that is going to be x by 2. So clearly you can see this is 3x by 2 and this is x by 2. So distance is larger than displacement. Okay. Now here they have said a value which is a magnitude of displacement. Now what do we mean by this? So displacement is a vector quantity, you know very well. Okay, magnitude of displacement means just the scalar. Okay, what is the magnitude between the initial and the final points? Okay, now this path could have been in any way. So A could have gone to B, could have gone to D. Okay, again come back to B and then again it can reach C. Okay, so the displacement will not change because the initial and the final points are same. So that is what is the definition for displacement. Like it depends upon the initial and final positions only, whereas displacement depends upon the path traveled. Okay, and there is a particular condition in which the distance and displacement can be equal. Okay, usually distance is always greater than displacement, but in one particular case it is going to be equal, and that will be, so if the particle is traveling from A to B in a straight line without turning back. Okay, the particle does not turn back, so it is traveling in the same direction in a straight line. Same direction in a straight line. Then in that case, you can say that distance is equal to displacement. Okay, so this is the idea behind. Now, distance is always greater than or equal to the magnitude of displacement. So I'll write magnitude of displacement. Okay, this is a fact. So distance cannot be less than the displacement. Okay, displacement can be less than or equal to the displacement. So you know at which condition they are going to be equal. Now the same logic you can apply for average velocity and average speed. All right, so if the particle is going to have calculate the average speed, okay, so V average is going to be total displacement by time. Total displacement by total time. Whereas average is speed. So this is, let me say, velocity average. Okay. So V average, that is the speed average, will be equal to total distance divided by total time. Okay, so clearly you can see only if the distance is equal to the displacement, they both can be equal. Otherwise, they both are not equal, and generally speed is more than the displacement. Sorry, speed is more than the velocity. So speed average is greater than or equal to the magnitude of velocity average. So this is what we understand from this question. Okay, so always speed is greater, average speed is greater than average velocity, and average displacement is greater than, sorry, average distance is greater than displacement. Next question is 3.14. A man walks on a straight road from his home to market 2.5 kilometer away with a speed of 5 kilometer per hour. Finding the market closed, he instantly turns and walks back home with a speed of 7 kilometer per hour. So they are asking us to find out what is the average velocity, magnitude of average velocity and average speed. Okay, so two things they are asking to find, that is the magnitude of average. So before that, let me just write the inputs. So a man walks on a straight road from his home. So let us think that this is a home and this is a market, right? Which is 2.5 kilometers. So this length is 2.5 kilometer, and he is walking from A to B with a speed of 5 kilometer per hour. Okay, and he returns back with a speed of 7.5 kilometer per hour. Alright, now we have to calculate what is the magnitude of average velocity at different time intervals. So they have given the different time intervals 0 to 30, 0 to 50 minutes and 0 to 40 minutes. So first we have to understand how much time this man is going to take, okay, to reach from home to market. So from home to market, this man is going to take a time which is equal to the distance divided by the speed. So since this is going with an average speed, I mean the constant speed, here average velocity and average speed in the same direction is going to be same. So I can write distance by average speed, right? So that will be 5 kilometers. What is the distance? 2.5, which is going to be 1 by 2 of an hour. Okay, what is 1 by 2 of an hour? That is equal to 30 minutes, right? So from 0 to 30 minutes, this man, okay, in case 1, from 0 to 30 minutes, where is this man going to go? So he is going to go from home to market. Home to market. That is the time that it takes. So what is the V average? So V average is equal to total displacement divided by total time. Right, I'll write here velocity because sometimes we represent speed also with V. So what is the total distance? So velocity average is going to be, the total displacement is 2.5 kilometers divided by 0. Or I can write 1 by 2 of an hour, right, which is nothing but 5 kilometer per hour. So as what was given in the question, the same answer you're going to get. But and what about the average speed? Okay, so average speed will also be same, because here the particle, the object, the man is not turning back or changing his direction. He is just going in a straight line, in the same straight line, the equal speed in the same direction. Okay, so his average speed will be total distance by time. So here distance and displacement are equal. Total distance by total time. Total displacement distance by total time, which is also 2.5 kilometer divided by 1 by 2 of an hour. Okay, so here once again you're going to get 5 kilometer per hour. So in both the speed and velocity average are going to be same here, right? So this was case 1. Now what about case 2? Okay, so in case 2, this man is going to, we have to find out the average speed and average velocity from 0 to 50 minutes. Okay, now we know very well that from 0 to 30 it is going to travel up to A, from A to B. So here it is going to take 30 minutes. Now they have asked it till 50 minutes. So 50 minutes means he is going to go back, and the time that it is going to travel in this direction is 20 minutes. So therefore totally you are going to get 50 minutes. Now how far will the object travel in 20 minutes? So he is traveling with a speed of 7.5 kilometer per hour on his way back, right? So 7.5 kilometer is V2. All right, and the time taken, let us say from B, it is equal to 20 minutes. So what is the distance covered? So the distance covered will be, so 20 minutes can be written as 20 by 60 of an hour. Okay, so it is 1 by 3 of an hour. So I'll write 1 by 3 h. So distance is equal to speed into time. So 7.5 into 1 by 3, which is nothing but 2.5 kilometers. Okay, so that means the particle is going to come back to his original place in 2.5 kilometers. So meaning in 20 minutes he is going to reach this point A. So what we thought earlier that it would reach midway between, but actually in 20 minutes it's going to come back to his home. So now what is the displacement? What is the total displacement of this object, of this particle, of this man? So displacement is 0. So I can write total displacement is 0, and total distance will be 5 kilometers, because 2.5 it has gone from home to market and 2.5 from market to home. Therefore velocity average is going to be 0 by 50 minutes, which is nothing but 0, and speed average, okay, speed average is going to be 5 kilometers divided by 50 minutes. So I'll convert 50 into hour. So I'll be getting 6 kilometer per hour. Right. So this is the average speed and average velocity. So clearly you can see they are not equal. Okay, and average speed is greater than the average velocity. So always this is the idea. Okay, so average speed can never be less than velocity. It has to be greater than, or at the max it can be equal. So where it was equal, like in the previous case we saw that they both were equal. But now they are different. Now the next case is what happens when the particle is going to go from case number 3, the particle goes from 0 to 40 minutes. Okay, so we know very well from A to B, he is going to take 30 minutes time, and then an additional 10 minutes, he is going to cover half of the distance. So because we know already that it is going to take 20 minutes to cover the whole, so in 10 minutes it will be covering half of it. So it is going to be 2.5 plus 2.5 by 2. Alright, so which is going to be 3.75 kilometers. Okay, so 3.75 kilometers is the total distance. So I'll write here total distance is equal to 3.75 kilometer. And what is the total displacement? So the total displacement will be, so from A to this point, what is this length is equal to 1.25 kilometer. So your average speed and average velocity will be, so velocity average is equal to total displacement by total time. So total displacement is 1.25 divided by total time is what, 40 minutes. So 40 by 60. So that is going to be 0 0 cancel, 6 into 1.25 divided by 40, and it can, sorry, not 44. So 3 by 2, and 1.5 into 1.25 is going to be 1.875 kilometer per hour. So this is the velocity average, right? And we will check on the speed average. So speed average will be 3.75, that is the total distance, divided by 40. So 40 minutes is 40 by 60. So 0 0 cancel, 6 will go to the numerator. So 6 into 3.75 by 4, and this is going to be 5.625 kilometer per hour. Right, children? So this is how you're going to solve this question. Now look at 3.15. It is a continuation or next, or just an additional conceptual question for the two questions that we solved earlier. So you have seen that the average speed and average velocity have some differences when we calculate, right? But what about the instantaneous speed and the instantaneous velocity? So instantaneous means at the moment, okay, at a particular moment. So in reality, at a particular moment is not possible. You cannot have a time, exact time. Okay, there has to be a time interval. Okay, at a particular moment is not really possible. So what we do, we reduce the time interval so much that it is almost equal to 0. Okay, so we make delta t almost equal to 0. So in that case, what happens is the average speed or average velocity, whatever it is, so the delta s by delta t, okay, where the limit delta t tends to 0, okay, the displacement or the distance is going to be equal, because if a particle is traveling in a particular path, okay, if you're going to consider a very small period of time, that short period, however curved your path is, in that short time interval, the path is going to be a straight line. Okay, and you know very well that if the particle is traveling in a straight line, then its distance and displacement are equal. So if distance and displacement is equal, then it means that velocity and speed will also be equal. So this is represented as ds by dt. Okay, and here if you simply write ds by dt, it is going to be a scalar. If you are going to write ds vector by dt, then it is going to be instantaneous velocity. Okay, so velocity is going to be ds by dt, whereas speed is going to be ds by dt. Okay, so the only difference here is if you take the magnitude, you are going to get speed, because there is no distinction between the magnitude of velocity, the instantaneous magnitude of velocity, and the instantaneous speed. They are all one and the same, because in a very short time interval, we tend to believe that distance and displacement are equal, because in that very short time interval, the particle is going to travel in a straight path, irrespective of what it was traveling in the whole time. So from 0 to t doesn't matter. It only matters in a very small time interval, delta t tends to 0. The particle is going to be in a straight line path. Alright. Now look at this question 3.16. Look at the graphs A to D carefully and state with reasons which of these cannot possibly represent one-dimensional motion of a particle. See, one-dimensional motion does not mean that the graph must be a straight line. Okay, please be very clear with this, children. One-dimensional motion does not mean the graph should be a straight line. Okay, so it can be a curved path also, but there are certain rules. Okay, now look at the first graph. This graph is not possible because at a particular time interval, you can see that there are two values of positions. Okay, where here x is position. So in the same time t, you are having two values of x. So which is not possible. How can a particle be at two positions at the same time? Okay, so this is not possible. Therefore, the first graph is not possible. Right? What about the second graph? Again, the same argument. So this is v versus t, speed versus time. And in a particular time, you can see that the particle is having two different speeds. So which is not possible at all. Alright, and look at the third graph. So in the third graph, you are having speed in the negative axis. So speed cannot be negative. Okay, speed can be positive or 0, but it cannot be negative. Therefore, the third graph is also not possible. What about the fourth graph? So in the fourth graph, you can see this is the total path length. Okay, so if the particle is starting to move, okay, total path length means it is the distance covered, right? So distance covered also cannot become less than what it was before. Okay, so because from 0 to this time, it has covered some length. Okay, so either it can maintain the same length or it can go further up more, but it cannot reduce. Okay, how will the distance reduce? The distance covered cannot reduce. The displacement can change, but the distance, once if it is leaving the reference point, the distance always is greater than 0 and increasing. It cannot decrease. Okay, so the four graphs are not possible and do not represent one-dimensional motion of the particle.